All right, so this is just the notes that we did in class on 311. So I'm going to go over those again in the video for any students that weren't there, or if you want to rewatch. All right, so landfills and sanitary landfills. This is what we've been setting up in our lab. So you guys probably have some idea right now about how that's working. So leachate, just a couple definitions, is any liquid that contains elevated levels of pollutants as a result of having passed through municipal solid waste or contaminated soil. Basically what this means is rainwater falls on the landfill or on contaminated soil, it picks up the pollution and it drips into like the groundwater. That leachate that's coming out of the landfill once it's gone in and picked up some of that waste, that's what we're trying to avoid mostly. The sanitary landfill is some facility that is designed to hold the waste without producing leachate, basically. What we want to do is to have a liner, typically like clay, so a soil layer of clay, because clay is fairly impermeable. And then on top of the clay, you would put a like rubber or some other sort of material liner, almost like you're making a swimming pool. Then you would put the refuse in and you would periodically cover it with dirt. About 20% of a sanitary landfill ends up being dirt. And then when you're done, you cap it so that the rainwater can't just get in. Now, this is great. However, most sanitary landfills are going to leak. I didn't have this stat in class, but let's go ahead and look up what percent. Let's just do landfills. Landfills leak. No, all landfills leak. Okay, but that's just a blog. That's an environmental blog. Here we go. This is what I was looking for, the USGS. All right, so this is from 2003. So 57% of the waste is disposed of in landfills. Precipitation and groundwater, which is many studies have shown leachate plumes. Estimates for the number of closed landfills in the US are as high as 100,000. All right, so it doesn't have a set percent. I know I've seen one cited before. If I can find it, I'll go ahead and put it online. I don't want to waste a whole bunch of time like looking for this unless I can find. Oh, that's about the production of methane, which we'll talk about too. But all right, so we'll go back to that at some point. Okay. The tipping fee is how much you have to pay to dispose of material. In either a landfill or an incinerator, it's going to be more costly at an incinerator, and we'll talk about why. Historically, landfills were inexpensive and convenient. Now, the big problem is siting, and we talked about this a lot in class. Got kind of off topic, so I'll try to stay on topic here. But suitable sites are becoming scarce because we want to put a landfill in a spot that is good geologically. It has the good like impermeable types of rock or soil. It's not geologically active. We don't want to put a landfill in the middle of a fault zone. But also, landfill sites are not just about the science. They're also done through a regulatory process with studies, the written reports, and then the public hearings. So people who have time and or money often are able to say, I don't want this landfill here. So landfill siting is part of this NIMBY. It falls into this NIMBY category of environmental justice or injustice. And sometimes it's even called environmental racism because oftentimes in the US, this ends up affecting communities of color much more than white communities. So there is this NIMBY attitude, not in my backyard, about these landfill sites. A site may be chosen not because it meets the safety criteria, but because better options have neighbors that don't want them. So this is one of those issues. We see this a lot in environmental science with this environmental injustice. We're going to talk a little bit more about this component a different day. We're going to actually do like a case study about it later on. So we'll come back to that. All right, now the environmental consequences, there's always the possibility that leachate is contaminating water as it goes out of the landfill, and it can go into the groundwater. It can contaminate drinking water. The EPA estimates that virtually all, there it is. I didn't have a percent, but I just have virtually all. Landfills in the US have some leaching. After the landfill is closed, we still have the potential for harm. If you don't remember it, make sure you know the Love Canal example. That was one of the case studies way back from the beginning of the year. And the Love Canal, just to kind of show you where you can find information. Wikipedia would be great for this one. It's going to give you all of the like specifics that you need, probably even more. Or the EPA even has a story written, EPA Journal from 1979, which is right after this whole thing happened. So that would be a great source too. But basically what happened was we had that Love Canal landfill, and there was leachate escaping, and they ended up covering the landfill. It was closed, and when they covered it, they put neighborhoods and a school nearby, and a lot of people started to get sick. So that's a big problem. Now, one of the good things about modern landfills is we can do what's called methane recovery. So we can actually look at anaerobic bacteria, adding them into the landfill. Many of them will already be there, but you can add more to get more methane and CO2. The methane is an explosion hazard. There have actually been landfills that explode. So they usually, even if they cap a landfill, they'll need to drill in some holes to let gases escape. However, what they can do and what they've worked on doing now is put these methane extraction tubes in. So as the gas is produced, it goes into these like porous pipes, and it can be piped out into another facility. That methane can then be used as almost like a fossil fuel. You can use it to generate electricity. All right, so these are just the steps for using landfill. Here is your methane information. This one also has what's called a leachate collection system. So they're trying to maintain the leachate and remove it from the system to be processed instead of letting it get into the groundwater. But you'll notice that the groundwater is here, and we've got multiple layers that we're hoping are going to block it, but we also have a groundwater monitoring well. So that well is going to try to monitor that groundwater as well. All right, so incineration. Like I said, it costs a little bit more. You guys know what a fire is. The bottom ash is the residue that, like, from the fire that would collect at the bottom. So it is literally like the bottom ash. So here's your combustion chamber. The bottom ash would fall out here. The fly ash is the stuff that would go out like smokestacks. The residue collected from the chimney or exhaust pipe. Now, when we do this, we are not just going to burn the waste. Now, some people will. You can do this in the country, but not in the city. But if you burn it, you can use it to do something else. So you can use it to generate electricity. You can use it to do lots of different things. Usually, incineration is going to be used to generate electricity, or it can be used to like heat a boiler, which will then, that will go to generate electricity. Or sometimes you'll see it used for like on-site electricity. So not like a power plant kind of electricity, but like electricity for stuff right nearby. So this is what we call waste to energy. So heat generated by incineration is used as an energy source rather than just released. Now we do have environmental consequences. So because like this is somewhat better, we're, instead of burning fossil fuels, we can burn methane, which is a greenhouse gas, and produce a less bad greenhouse gas, CO2. But we have some other issues. So first, tipping fees are higher, and tipping fees have to be higher because of our next kind of thing. The incinerator can release air pollution, So we have to have multiple steps, as you see here, to remove air pollutants. So electrostatic precipitators, which use charges to get particles out, and then filters before the air is released. They also produce ash that is much more concentrated with toxins. So if you think about it, if you're throwing a bunch of stuff in your trash can, say you throw like some dead batteries in there and a banana peel and part of your sandwich from lunch, and then all of that goes to be incinerated. The banana peel, the sandwich, those are going to just burn up. You're not going to have anything toxic from that. The batteries, though, the batteries might contain different toxic chemicals that we wouldn't want anywhere, really. So now we have this ash that contains toxins. So this ash here that is sent to the landfill at the bottom of that image has to be treated as hazardous waste. So that's why it's going to be more expensive. All right. And yeah, that's all we did today. So make sure you understand that stuff. And that's it. If I can stop it. There we go.